So for the warm-up, I didn't really have you look at the warm-up to do this because I'm probably going to show you a different way to do this than you were shown. Alright, so looking up here, don't write this down. How many of you were taught whenever you're just to simplify radicals to try to divide it by 2, and then you take that and you divide it by 2. Do you remember that stuff? Raise your hand if you remember something like that. Okay. I'm going to show you another way to simplify radicals. I think it is a lot quicker because if you get a bigger number like 108, that process feels like it just never stops. And it just goes on and on and on and on. Okay. So to do it the way that I'm going to show you, you do have to understand, and it's not a hard concept at all. In fact, you probably already know it. You just either haven't heard it called this or you just never really thought about it, which may be the case. Somebody tell me what a perfect square is. And by that, I don't mean a nice, neat shape square. Do what? No. So not the shape of square, but what is a number that is a perfect square? What does that mean? Okay, so 4 times 4 is 16, so 16 is a perfect square. It's really easy to get this list of numbers. Okay? Because what is 2 squared? What is 3 squared? 4 squared? 5 squared? Okay, and so on. So all of these numbers, and we'll just stop at 49. All of these are perfect squares. Okay, so we're going to use this list of perfect squares to easily simplify this. And what you're going to do is you're going to take the number that's underneath the radical. You're going to try to find the largest number that you can divide 52 by out of this list. So I would start and it divide evenly. So can I divide 52 by 49 and it come out evenly? No. 36. 25. Not evenly though. 16. No. 9. Because it goes 36 and then 45 and then 50. What if I'm multiplying by 9s? It goes up to 54. Can I divide it by 4? Yes. Okay. Yes. So on this one, 4 is even though it's the smallest perfect square, it's the largest one I can divide 52 by. So I'm going to rewrite that. Whenever I divide 52 by 4, what do I get? 13. What is the square root of 4? So I take 2 out. And if I didn't take the square root of it, I leave it inside. And that's simplified. Okay, so let's do it again on 2. What is the largest perfect square I can divide 20 by? 4. 20 divided by 4 is what? Okay. And what is the square root of 4? And you don't have a whole notebook paper full of some little weird tree method that takes forever. Okay? Now, whenever you get to a bigger number, 108, and feel free to grab your calculator and do 108 divided by 49. No, doesn't come out evenly. Then do 36, and then do, okay? So does anybody already have this one figured out? What can I divide 108 by? 36. 108 divided by 36 is what? What's the square root of 36? Okay, and I know that one specifically, again, if you did the tree method, that one takes a while. Trying to divide it by 2s and trying to divide it by 3s. Okay, now I had a pretty good question yesterday of what if I accidentally mess up and I don't divide it by the largest perfect square, but I divide it by one that I can divide it by. So maybe you did this one and you did, so just kind of, you don't have to write this down, just follow me. Let's say you just missed 36. You forgot to check it, whatever, and you do 4. Okay, 108 divided by 4 is 27. Okay, so the square root of 4 is 2. Can I divide 27 by a perfect square still, though? What? 9. So I could rewrite that as 9 times 3. The square root of 9 is 3. Whenever I pull it out, I'm going to multiply it by that 2. And I end up with the same answer. Okay? If you pick if you do get the largest perfect square, you don't have to go through that process twice. Okay? But you just need to make sure, can I divide that number, can I divide 3 by a perfect square? No. Can I divide 5 by 1? No. Can I divide 13 by a perfect square? No. Okay, so that tells you that it's as simplified down as you can possibly get it. Yes?
How did you end up with the 3 by itself?
One topic in this whole class, this whole year, that most people struggle with. Okay? But again, I'm going to show you a different way to do it that maybe it'll click. Alright, you talked about factoring. Trevor Shelley, please keep your head up, please. Okay? You talked about factoring in Algebra 1. And you were probably shown the box method. And you put one thing here, and you put another thing here, and you got to find the factors of one number that add up to another. Raise your hand if you remember that process. Okay, I'm going to show you a little different way whenever we get to that factoring that stuff. If you want to do box method and you're comfortable with that, awesome, do it. Okay, I'm just giving you options here. So, let's kind of back up and just talk about what we're doing whenever we're solving. Okay, on all these we're going to do what is called solve by factoring. So the two things you need to make sure that the equation is set up for are these two. You got to make sure that it's set equal to 0. So 1, 3, and 4 we're fine. On number 2 we're going to have to move some stuff over because it's not set equal to 0. So you always check that first. After that you've got to check see if you have a greatest common factor. Okay, those are always the first two things you check for, always. Sometimes, after you've done the greatest common factor, you're done factoring. You don't have to do the box or the little way that I'm going to show you in a minute. Okay, you're done factoring. All right. Once you've done that right there, and I kind of add a step here, so you might add this, you're going to figure out, is it one of 3 situations? And we're going to talk about all 3. Is it no B? Is it no C? Or does it have all 3 terms? Okay? And whenever I say no B, no C, I'm talking about that standard form. Okay? Whenever you factor it, it's always going to be in the standard form. You're never going to have a problem that does not have an A term. Because if it does not have an A term, it's not quadratic, it's linear, and this whole lesson would just be useless. Okay? You wouldn't have to do it. You're just not going to have it. Alright, so once you factor it, we'll set each factor equal to 0, and we'll solve for x. Whenever you're asked to solve for something, make sure you know what that is telling you to do. That means that your answer is going to end up being x equals. If you're asked to solve, you're solving for a value, your answer will be x equals. Okay? So I'm going to copy this, put it back down. Alright, so looking at number 1. Set equal to 0. And even before the greatest common factor, you can probably do this part. Am I missing my B, my C? Am I missing a B term or a C term here? C term. Okay? So this is the no C problem. On these, all you're going to have to do is find the greatest common factor, and you factored the problem. What is my greatest common factor on this? For what? For x. Both terms have an x. So I can pull out an x, and I end up with x minus 3. Okay, if you have if there is no c value, at the very least, you can pull out an x. Okay, let's say that 4 wasn't there, it was just x squared minus 12x. At the very least, you can pull out an x. And now it's factored. Yes, ma'am. How did I get the what? 12x divided by 4x is 3. Alright, so I've got it factored. Now I'm going to set each factor equal to 0. What is 0 divided by 4? And what root is that going to give me, the x minus 3? What do I need to do to solve for x there?
Add to the other side.
Just add 3. So going to number 2. Dylan, Liable, what do I need to do to it first?
Equal to 0.
Okay. If your x squared is positive, move everything to the x squared side. Alright, you want that x squared to stay positive. So I'm going to subtract 2x, and I'm going to subtract 15, and actually I need to write this off to the side with how we're going to do it. Alright, so this next method, this is replacing the box method. How we're going to do this. Alright, whenever I'm factoring these, you're always going to see me write this little triangle thing. What is in front of that x squared? What's understood to be there? 1. What is 1 times negative 15? What is 1 times negative 15? Negative 15. Alright, once I have that, underneath, I'm going to go ahead and write this right here. And it's going to be that factored form. Okay? And then I need to figure out what factors of negative 15 add up to negative 2. Anybody figure that out? So 2 numbers that multiply to negative 15, but add or subtract to negative 2. CJ?
Negative 5, 3.
Okay, negative 5 and positive 3. So if it's negative 5 and positive 3, and that replaced the box method. Okay, I've got it factored. Alright? So now I take each one of those, and I set them equal to 0. So this one gives me 5. The x plus 3 will give me negative 3. Now I do want you to know, if these problems said to factor, we would go, if it just said factor, we would go to that step and we would stop. Okay, we're done. But if it says to solve, we've got to do that extra step to get there. A lot of people kind of get lost in when they need to stop and when they don't. Alright? Yes? So let's go to 3. It's set equal to 0. Am I missing a B or C term? B. Okay, B has X on it. Okay, that negative 25 is the C term. So this is what I call just the no B. And on this, you're going to take the square root of your 2 terms. And let me kind of explain what I mean there. Every time you have this, it is always going to be minus, and it is always going to be perfect squares. This exact situation, if you hear something called the difference of squares, this is it. Okay? What is the square root of x squared? What is the square root of 25? Okay. What'd you say, Sean? It's 5 and negative 5. So that means one of your factors is x plus 5. One of your factors is x minus 5. And you've got it factored. Okay? You've got to identify it as a no B problem in order to do this. No C is just greatest common factor. And then you set each one equal to 0. You get negative 5. And you get positive 5. Okay, let's go to number 4. It's set equal to 0. I'm good there. Greatest common factor. There isn't one. So now I'm going to do something similar to number 2. Alright, I go here. 2 times negative 3 is what? Negative 6. So I'm going to come down here. I'm going to go ahead and write that out. And can somebody tell me what the factors of negative 6 are that add up to positive 5? Factors of negative 6 that add up to positive 5. Okay. Okay, positive 3 and positive 2 add up to 5, but 3 times 2 is positive 6. So it's not 3 and 2. Do what? 6 and negative 1. Okay. 6 times negative 1 is negative 6. 6 plus negative 1 is 5. Okay, so everything is the same up to this point. What makes this different is the coefficient of 2. So you've got to, whenever this is not just x squared, you know there's going to be an extra step. When it's just x squared, like number 2 was, this is all we got to do and we're done. Alright? Whatever number that is, that coefficient, I'm going to try to divide those two numbers by whatever that is. This one's 2. Okay? If it divides evenly, which does 6 divided by 2, does that divide evenly? Yes. I'm going to divide it, and I'm going to leave it alone. Does negative 1 divide evenly? No. So I'm going to take that 2, and I'm going to move it to the front of that right there. If you prefer doing box method to what I've just shown you, do box method. It accomplishes the same thing.
So you only move the...
And then I will take those 2. There is one root, and there is the other root. Sorry, 6. That has 16 in it. What do I need to do first to this? Set it equal to 0. No greatest common factor. 1 times 48 is 48. Can somebody tell me what factors of 48 add up to negative 16? Okay, so factors of 48 that add up to negative 16. Negative 12 and negative 4. So negative 12, negative 4. So my factors, or my roots, are 12 and 4. We're not going to go all the way through 7, but What is the first thing I would need to do on 7? What would the greatest common factor be? 4. Okay? And then you can just do the same thing there. Now, we need to be clear on what exactly it is we're solving for here. Whenever we're solving for these on the graph, you need to know all of these are the x-intercepts. Okay? So if I have a parabola, for example on 3, this is crossing at -5 and 5. That's what I'm solving for. Okay, on number 1, it's crossing at 0 and 3. Okay, so 0's right there, 3's right there. So make sure you know exactly what it is you're solving for whenever you're doing this factoring stuff. All right, let's go to the back. Alright, so on here, we're doing the process we just did, we're doing it backwards. So instead of getting to the roots, the x-intercepts, it's giving this the x-intercepts, and it's wanting us to go backwards to standard form. Alright, so Peyton, if the two roots that they give me are 2 and 7, what factors would give me roots of +2 and +7? X minus 2 and x minus 7. And then what do I need to do to that factored form to get to standard form? What is that method called? FOIL. If you prefer to do box on that for multiplication, you can. Yes, it's a form of distribution. Distributing the first x to the second binomial, -2 to the second binomial. Once you get that, you know where I got all of that, I want you to attempt number 8. There's 8. Alright, so next we're going to talk about the quadratic formula. Now you don't have this table on here. I'm just going to talk about it real quick and then we'll get into the problems. You've talked about the quadratic formula before. It's that really long one that no one likes. But we need to use it whenever we have a situation where we can't factor it. There is part of the quadratic formula you need to know about, and that is what is called the discriminant. It's the number underneath the square root. And we'll talk about this in a little more length next class. If that discriminant is greater than 0, which that's another way of saying that the number is what? Positive. You're going to have two real solutions. It's going to cross the x-axis twice. If you find your discriminant and it's 0, underneath the radical you get 0, then the vertex is going to be on the x-axis. And then if you get the discriminant and it is less than 0 or negative, you're going to have two what we are going to call imaginary solutions. That box right there, that last column on the table. Next lesson is over that, getting into detail of what does this mean. Okay? Other than I got a parabola that doesn't cross the x-axis. Okay? So that is, a lot of times that can be a little bit of a headache, but we'll take care of that next class. So we're just going to do a couple of these, 11 and 13. So you can use the space under 12 if you need to. So to do this,
We're not doing 12?
no. So on these, you need to identify what your A, your B, and your C terms are. Okay. So on that, Delaney, what is my A value?
1,
B value?
10,
C value?
12.
Once you have those, you're just going to go through the quadratic formula and plug it all in. So I've got negative B plus or minus the square root of B squared minus 4AC all over 2A. Now, different people have different strategies on how to attack that and how to simplify it down. Obviously, I'm going to show you how I do it, but first thing I do is I'm going to go through and I'm just going to get rid of all the parentheses just to kind of clean it up. So at the beginning, I would have negative 10. I've still got plus or minus. Then I have the square root. 10 squared is 100. Okay, so most of the time I'll do the b squared, and then I'll do negative 4 times the a times the c. So negative 4 times 1 is what? Negative 4. And then times 12 is negative 48. 2 times 1 is 2. All right. After that, I just do the little problem underneath the radical. 1 minus 48 is 52. And going back to the warm-up, this is why we did the warm-up, because you will need to simplify the radical. Okay? So you'll take 52. Normally I'll just kind of go off to the side. And this is one of the problems we did. What was the largest perfect square you can divide 52 by? What was it? 4. Okay, this is the very first one we did. It was 4 and 13. And the square root of 4 is what? And then I will rewrite where I'm at with 2 square roots of 13. You get to this step, you need to look to see if you can simplify the two fractions, and that's where they're at. It's the negative 10 over 2 and the 2 over 2. You will never divide what is underneath the radical, 13 in this case, by the denominator. Okay? So negative 10 divided by 2 is what? Negative 5. 2 divided by 2 is what? 1, which I don't have to write. Okay, so I can write this as my answer. Alright, where the plus and minus comes into, that's how you get, if you do it with plus, you get one x-intercept. You do it with minus, you get the other one. Alright, and if you're finding the decimal of these. Okay, so Carson, will you put that into your calculator and tell me what you get? Tate, will you do the negative 5 minus the square root of 13? And tell you what you get. 10 divided by 2.
Where did the 2 go?
Do you know anything with the ones?
Do what?
Do you do anything with the one? I'm going to multiply.
Where did the negative 2 go?
No.
Good job. Negative 8.6.
You got what? Negative what?
8.6.
Is it 6.1? 6.05?
Yeah.
Carson. Okay, so these two right there are the two answers. Okay? Sean, what was your question? Yeah.
How come I understand the negative 10 divided by the 2 at the bottom, but where did the 2 go for the 13?
This one?
Yeah.
You're going to divide this by that.
So you're doing a 3-way division right there?
Kind of, yeah, if you want to think of it that way. Because if you got a numerator that's split up by plus or minus, okay, and it could be plus by itself or minus by itself, that can also, that can also be written as two fractions. Like that. We just write it as 1 because it has that common denominator. And it always will. On these. On this, yes. Yeah. And then you would just divide it. So those cancel on that. Alright, let's go to the next one. I'm going to go through the first part of this really quick to get to the point that I need to show you on number 13. So I'm going to go through another way. If you don't want to go outside and write A equals B, or whatever, sorry, A equals whatever, B equals whatever, C equals whatever, just write A, B, C on top of it. Okay, but that's telling me that you're going through the process that I want you to. So I go through here. I've got negative B. Okay, make sure you know that if the B value itself is negative, you have to put this. This negative belongs to the B value. This negative belongs to the formula. So you have to have both in there. So negative B plus or minus the square root of B squared minus 4AC all over 2A. And again, the first thing I'm going to do is I'm going to go through and I'm going to get rid of all my parentheses. So that 10 becomes positive. Negative 10 squared is 100. Alright. Negative 4 times 1 is negative 4. Times 34 is negative 136. All over 2. So I have 10 plus or minus the square root of negative 36 over 2. Alright, Allie, put the square root of negative 36 in your calculator and tell me what it says. Error. Because you can't take the square root of a negative number. Okay? So your answer to this, until we have that lesson next class that deals with this is how we're going to get those imaginary numbers. But you run into this on the homework, your answer is no real solutions. Okay? Because your solution will be what is considered imaginary, which we'll learn about next class.